one, did you know about Antoine Henry Becquerel? Antoine Henry Becquerel lived from 1852 to 1908. He died at 56 years old. He was born and educated in Paris. His grandfather, his father, including his son, were also physicists. All of them were professors at the Paris Museum of Natural History. Like his grandfather and father, Becquerel specialized in fluorescence and phosphorescence. Those are phenomena in which a substance absorbs light at one frequency and remits again at a lower frequency. Becquerel thought that X-rays might result from exposing phosphorant materials to sunlight. He thought that intense light might stimulate a fluorescent material to give off X-rays. Now, let's witness the process of experiment.
Experiment number 1, February 24, 1896.
Becquerel extruded crystals of potassium uranium sulfate. He left them for several hours. Then, he placed them with a coin on top of a photographic plate. His prediction was that the plate would be bleached by the light from the glowing salt. The coin would block the light from the part of the plate.
After several minutes and hours, he said,
That's good.
There was an outline of the crystal and the shadow of the coin. My prediction has been proved correct.
Really?
He was worried that perhaps chemicals from the uranium crystals had been affecting the plate. So, he repeated his experiment by putting up a thin sheet of paper between the crystals and the plate to prevent chemical contamination. But
The effect was just the same as before.
experiment number 2, February 26 to 27, 1896.
He wanted to repeat his experiment with the uranium salt. So, he set the crystals on fresh photographic plates by the window. But, unfortunately, it was a dull day. No sunshine. He waited again until next day, but still no sunshine. So he kept the uranium salt with the plate in the same drawer. To his surprise,
The effect was just the same as before. Without exposure to sunlight, perhaps the action could take place even in darkness.
so this given him an idea to conduct. Without this accident, this has led him to conduct again another experiment.
Experiment number 3, March 1, 1896.
He took several photographic plates and several crystals of uranium salt. He placed one crystal directly on the photographic plate. Second, with a glass in between. Then third, he placed an aluminum sheet on top of the plate. After that, he said,
This first, which is in direct contact, showed strong blackening. The second, slightly weaker blackening. While this third much weaker, but very clear. I am now convinced that uranium salt produces invisible radiation, even when they have been kept in dark. They do not have to be kept exposed to sunlight to produce this effect.
Number 4 and 5, March 9, 1896.
He kept the uranium crystals in dark for 160 hours, almost 1 week. After that,
there is no sign of decrease in the intensity of the radiation which they produce.
He also discovered that the radiation from uranium salts can have an electric effect. It can remove electric charge from a body which have previously charged with static electricity.
this was his final experiment. After he had done this, he published all his findings, and he received the Nobel Prize in Physics in 1903.
May 18, 1896. At first, I thought that uranium salts were of interest because they showed phosphorescence. Then he discovered that they gave out radiation even when they had not been placed in sunlight. In his most recent experiments, he have looked at uranium salts, which do not show phosphorescence. These are equally capable of blackening photographic plates. We have now looked at many substances containing uranium. It doesn't matter whether they are in the form of crystals, melted, or dissolved in water. They have the same effect. He has thus been led to think that the effect is a consequence of the presence of the element uranium in these compounds. He was led to predict that the pure metal uranium would have an even stronger effect than of its compounds. It was confirmed by his experiment using powdered uranium metal. And this effect was named invisible phosphorescence.
Trivia. Did you know that Becquerel is not the only scientist who worked with uranium? In the United States, Sylvanus P. Thompson, and in Scotland, Lord Kelvin reported that uranium salts blacken photographic plates. Lord Kelvin reported that uranium could discharge static electricity. He gave a talk about this in Edinburgh on the evening of March 1, 1896. At exactly the same time, Becquerel was giving his first report on this subject to his colleagues in Paris. However, neither Thomson nor Kelvin carried out such a systematic study as Becquerel, and he is given the credit for the discovery of radioactivity. Wow.
That's the end of the presentation of the experiment of Becquerel.
Chemicals from the